Hey y'all, Miss Kennedy here from Algebra Student, and today we're looking at a graph and figuring out what the linear inequality is that created that graph. So it's very much a working backwards from what you usually have to do kind of thing. Sometimes there are parts of that are easier, and sometimes there are parts of that are more difficult. So we're going to look at each piece and see if we can make sense of it. And that's my goal. I want you to hit subscribe because I want for you to be able to make sense of algebra so that you can move on with your life. All right, so let's jump in. So first things first is that I see that there's a dashed line here. So I can go ahead and know right off the bat that I'm not going to have an underline or an equal to part of my equation. So that's not going to be a part of it. It's going to be one of these two. It's either going to be greater than or less than. And so I'm going to start by thinking, okay, that'll be my sort of last thing. I've got to get the equation part of it next. So I'm looking for where this graph crosses the y-axis, and it says y right here. I know this is the y-axis. This one crosses right at 0. So think about your y equals mx plus b form, because that's kind of where you're headed with this. That's what you're thinking. And b, in this case, b is 0. So for us, that means there's nothing that's going to be at the end of the equation. Oh, yeah, there we go. For us. So because it's 0, and we don't say plus 0, like you wouldn't say you're 16 plus 0 years old. You would just say I'm 16, even though technically you could say plus 0, but we don't do that. So, okay. All right. So then my goal is to think, okay, where's another point that's easy for me to find, as in not, like I don't want this point. You see how that's kind of just in the middle of a square on the graph? That I don't know if that's exactly 1.5 or over 1/2 and up 1.5. I don't know. That's really hard to tell. I wouldn't even choose this one because it's not quite all the way at 1. I don't know if that's over 3/4 of the way and up 2. So I don't want that one. But I do see this one appears to be exactly right 1 and up 3, right? So that's what you're looking for. You're looking for an exact point. We could have used 2, 6. I guess we could have used -1, -3, or -2, -6, but I would, I'm going to avoid negatives. I'm just going to try not to use them if I don't have to. That makes it easier. Okay, so now it's just a matter of rise over run. So think from 0, how far do you go up? 1, 2, 3. So you're going up 3. So that's your slope from, right here. Your slope is rise over run. So you're going up 3, and you're going to go right 1. Well, 3 divided by 1 is just 3. So I have the things I need now. I needed m and b, and b is just that y-intercept of 0. M is the slope. So I know that it's my answer. I'll put it over here. Y is something greater than or less than, I don't know yet, 3x, because the x is always part of the equation or inequality. And then there's nothing else. That's it. Like that, I'm almost there. That's almost the answer. I just have to figure out if it's greater than or less than. So, I want to pick a point, and usually we pick 0, 0 because it's usually the simplest, but 0, 0 is on the line, so I can't use that one for this. I need to pick a point somewhere else. For me, I'm going to try to pick positives just because they're easier to plug into usually. And so that's what I'm going to do here. So I'm going to pick 5, 1. I'm going to test 5, 1. Okay. So if it's y is greater than 3x, and I use 5, 1, that's my x and y, then 1 is y greater than 3 times 5. Okay. Is 1 greater than 15? Well, no, 1's not greater than 15. That would be false. So this should not be shaded. right here. And it's not shaded. So that means this is the correct answer. Greater than is the answer there. Okay. So let's say that we had tried y is less than 3x and we plugged in 5, 1. So 1 is less than 3 times 5. 1 is less than 15. Well, 1 is less than 15. That's true, meaning that this should be shaded if that's the inequality. It's not shaded. So this can't be the right one. So that could be confusing. And it may be that you're just like, no, I don't care about negatives and positives. I'm always going to pick where it's shaded so that if it works and it's shaded, then I know that that works. And that's not a bad idea. So let's look at the next one and let's use that to see how that would work. Okay, so we have a dashed line just like we did before. So that tells us that we're not going to use a greater than equal to, because it would be a solid, or less than or equal to. It would be solid if it was one of those. So it's got to be one of these answers. It's got to be greater than or less than. And again, we're looking for where does this line cross the y-axis. So the y-axis is here, and the line crosses here. So right down there at -1. So I know right off the bat that I'm going to have a -1 at the end. I don't know if this is less than or greater than. I know it's something x minus 1. All right. So remember, you're looking for 2 points. You've got this point here, and then I went ahead and highlighted a point here, but I wouldn't use this spot right there because it's not exactly on a simple place to find. You could use this point or this point, and it actually wouldn't matter. It doesn't matter which point you use, which is interesting because it's a fraction and it'll simplify to the same thing. So it's kind of cool that works out. So we'll use these two. So let's think rise over run. So we're going to go up 2. So slope is rise over run. And we went up 2. And we're going to go to the right one. Well, 2 divided by 1 is 2. So that's a slope of 2. All right, so we've got almost all of it. We just don't know greater than or less than. All right, so we just said we're going to use something in the shaded area. So I'm going to pick something that's shaded this time. Oh, let's go with 3, 1. That's shaded. That's going to be my test point. 3, 1. Okay, so let's see. Let's slide this up just a tad. All right, so let's say that I think it's y is greater than 2x minus 1. Okay, so if this is my x and this is my y, then I'm going to plug in 1 for y, 2 times 3 minus 1. Okay, bring down the 1 greater than. 2 times 3 is 6. 6 minus 1 is 5. Is 1 greater than 5? No, 1's not greater than 5, so that should not be shaded if it's greater than. But it is shaded, so it must not be greater than. You see what I'm saying here? So I'm thinking it's less than. I'm going to write that over there. Now let's test that and see. Oh, let's see where I want to write it. Okay, let's go over here. So let's try y is less than 2x minus 1. Plugging in 1 for y and 3 for x. 6 minus 1 is 5. Is 1 less than 5? Yes. This should be shaded. And it is. So that tells me this is the one that I want. So that is my correct answer for this problem. Now, usually we test 0, 0. And so we could have tested 0, 0 here. And since 0, 0 is not shaded, we should get a false statement if it's the right inequality. I know it gets confusing. I mean, I'm trying to make sure I'm saying all the right words because, I can hear the confusion in all of it. But just think, if you're testing a point and it's already shaded in the graph, then it should work if your inequality is right. So if it doesn't work, then the inequality is not right and you have to try the other one.